All right, here in section 4.7, we're going to talk about inverse trig functions. And so this is going to combine something that we talked all the way back in section 1.5 about, which was inverse functions. It's going to combine those ideas with trigonometry. And so we're going to start talking about the inverse sine, the inverse cosine, and the inverse tangent function. And so what does an inverse function do? And hopefully you can remember, it was about a couple of weeks ago here, that an inverse function switches the x and the y. And so what that means is that trig functions, your normal, regular, everyday trig functions like sine, cosine, and tangent, take as an angle, as an input, they take an angle. And then they return a trig function value as an output. And so what I mean by that is we know that sine of pi over 6 is equal to 1/2. And so the input of the sine function is an angle pi over 6, and the output is some trig ratio that came from one of those special right triangles that we talked back in section 4.1 through 4.3 about. And so what an inverse trig function does, and there's a couple of different ways to write this, and so if you'll kind of let me get ahead of myself, I'll show you both of those. What an inverse trig function does, and one way that we would write inverse sine is by sine to the -1 power, if you want to think about it like that, or really this is just read sine inverse. What it does is it takes as its input a trig function value, and as its output gives you back an angle. And so sine inverse of 1/2 would equal to pi over 6, where this 1/2 is the input of the inverse sine function, and pi over 6 is the output. And so when we talk about inverse sine, inverse cosine, inverse tangent, we are always going to be answering that question with an angle. Now, there will be some other times where maybe we're not explicitly asked what's inverse sine of, square root of 2 over 2, and in that particular case, the angle may not be the answer. But if the question is just sine inverse of 1, that's got to be an angle in return. And this could also be written in this arc prefix notation, arc sine of 1/2, and that just simply means the same thing as sine inverse, and so this would also be pi over 6. And we'll talk more about that notation a little bit later on in the notes, but for now what I need you to know is that the inverse trig functions switch the x and the y. And so now for the inverses, the input is going to be that trig function value, and the output is going to be an angle. Okay, so just revisiting some things about inverse functions, and this is going to help us develop the ideas here behind the inverse trig functions. We know that for a function to have an inverse, it must be 1-to-1, which means it must pass both the vertical line test and the horizontal line test. It is very obvious by looking at the picture here of this sine of x function, this does not pass the horizontal line test. And so what we are going to do is we're going to restrict the domain of the sine function so that when we take its inverse, it will be a function. Or another way to say that is we're going to restrict the domain so that sine of x is 1-to-1, so that it passes the horizontal line test. And we want to make sure that we get the entire range of the sine function. So what I mean by that is I could absolutely just take this part right here of the sine function, and yes, that absolutely passes the horizontal line test, but it does not encompass the entire range of the sine function. And so we want to encompass the entire range of the sine function, which we know is -1-to-1, and figure out what angles we need to take in order to get that entire range without taking more than we need so that it passes the horizontal line test. And so if you'll follow me here, I'm going to continue maybe using a different color highlighter. That yellow didn't show up quite as good as I thought it was going to. This green here is a little better, and so if I use this green, notice I can go all the way up to that very top maximum Before, if I turn the corner, so let's just say that I keep going here, if I turn the corner around that maximum, I no longer pass the horizontal line test. And so what that means is I don't want to cross over that corner. I want to stop at the very top of it. Now, going the other direction, we can go down so that we get the entire range, and we get down to -1, and that is where we want to stop things so that this green piece passes the the horizontal line test. And so which angles did we take? That's the question. Well, if this is -pi and this is +pi, this appears to be occurring halfway between 0 and pi, and so that right point here is going to be at the angle pi over 2, and then the angle on the left, again, is halfway between -pi and 0, and so that would be -pi over 2. And so if we restrict the domain of the sine function to -pi over 2 and pi over 2, that would still make the range what it normally is, which is -1 until 1. And now we're going to have a function that is 1 to 1 and therefore has an inverse. Okay, so this particular slide I think is going to hopefully help what I just said make a little bit more sense. And so when you restrict the domain of the sine function to the interval -pi over 2 to pi over 2, the following properties listed will hold. And so on that interval, the sine function is increasing. And you can see from here at this point up until this point here that yes, sine of x is increasing. More importantly, it takes on its full range of values, meaning all the way from -1 until +1, we're going to be able to get any value that we want there for the sine function. And then on that interval, sine of x is 1 to 1. Notice that this boldened end part will pass both the vertical and the horizontal line test. And so because that's true, on that restricted domain, sine of x has the unique inverse function called the inverse sine function, and there are two different ways to denote the function: sine inverse of x or arc sine of x, as I mentioned earlier. And then one helpful tip is that when you evaluate the inverse sine function, it helps to remember the phrase that the arc sine of x is the angle whose sine is equal to x. And so what I mean by that, just as a very basic example here, if I have sine inverse of the square root of 3 over 2, then the answer to that question is what angle has a sine value of square root of 3 over 2. And that's where knowing the unit circle will really be valuable to you here, because I know that sine of pi over 3 is square root of 3 over 2. And so the answer to that question would be pi over 3. Okay, here we want to talk about the domain and the range of our three inverse trig functions. And so starting with sine inverse of x, and so again, remember that there's another notation for that sort of helps avoid ambiguity, and so that notation would be y is equal to arc sine of x. And so if you see either of those two notations, they're talking about the same function. And so looking at the picture here, you can see that the domain of inverse sine is going to be from -1 until 1, and the range is going to be from -pi over 2 until +pi over 2. And notice that if you go back to one of our previous slides when we talked about restricting the domain on sine of x, this is actually the reverse of the domain and range that we wrote down. And remember, that's what inverse functions do. They switch the x and the y. Okay, for inverse cosine, again, the unambiguous notation would just be arc cosine of x. The domain is also going to be from -1 until 1, and the range is going to be starting at 0 and going until pi. And so what you're going to notice is that's a different range from inverse sine. It's going to be even different from inverse tangent as well, and so we're going to have to account for what that difference means whenever we go to answering problems. And the next slide will help us with that as well. Okay, for inverse tangent of x, the unambiguous notation would be arctangent of x. And to be perfectly honest with you, this is the most important function to have the graph memorized for calculus, because this function tends to show up quite a lot in our study of calculus. And so we need to know what it looks like. We need to know that it has horizontal asymptotes, much like the tangent function has vertical asymptotes. And so these horizontal asymptotes are at negative pi over 2 and at pi over 2. And so that domain is going to be negative infinity until infinity. There are arrows here. That means that this function keeps going. And the range is going to be from negative pi over 2, not including, because it's an asymptote, until positive pi over 2. And so I want you to notice the similarities between sine and tangent, and that cosine is completely different from those two, and that's going to become very important later on when we answer questions. Okay, this slide is simply designed to help you understand how to figure out what the sign of the answer, S-I-G-N by the way, positive or negative, what the sign of the answer is going to be depending on which quadrant we're talking about, or really whether we're talking about a positive argument or a negative argument. And so let me see if I can explain what I mean here. Let's say that I have sine inverse of positive a half. Well, the only two options for sine for the answer to be from is from quadrant 4 down here or quadrant 1 up here. But of those two quadrants, which of them has positive values for sine? Well, remember, this is all students trust Castle. Obviously, we don't care here about quadrant 3. Nothing is going to come from quadrant 3, but I see that if I have sine inverse of a half, that's a positive number. 1/2 is obviously positive, and so therefore this is going to have to come from quadrant 1, because down here in quadrant 4, that's where negative values come from for sine, and I don't want it to be negative. In this case, I want it to be positive. Now, on the flip side of that, if I have sine inverse of, let's just say, negative square root of 2 over 2, well, sine inverse of a negative has got to come from quadrant 4, and that's because sine inverse itself has to either come from quadrant 4 or quadrant 1, but because this is a negative, that means it's got to be in quadrant 4. So it's in quadrant 4, sine is negative. And so what I'm going to see here is that here in quadrant 1, that's where all of our positive values are going to be, and then our negative values are going to be either in quadrant 4 for sine inverse and tangent inverse, or in quadrant 2 for cosine inverse. And so what that means is that, let's say that you have sine inverse of negative square root of 3 over 2. Because that's sine inverse of a negative, the answer has got to be from quadrant 4, and more specifically, the answer has got to be between negative pi over 2 and 0. So you can't just say an angle like 7 pi over 4 or 11 pi over 6 when it's in quadrant 4. It's got to be on this specific range whenever you have sine inverse of a negative. And so hopefully through example, these things will start to become more clear, and if not, you guys can obviously ask me questions.